So here's an overview of the molecular view of elements and compounds. So looking at those particles. So pure substances are divided into elements and compounds. Elements are divided into atomic elements and molecular elements. In atomic elements, the individual particles are found as individual atoms. In a molecular element, they are found as molecules. In a compound, we can have molecular compounds or ionic compounds. Molecular compounds have molecules like water, where the hydrogen and the oxygen are bonded to each other with a chemical bond, and they form individual molecules. Ionic compounds have ions in them. That's not too hard to figure out. But in an ionic compound, we've got positive and negative ions, and they tend to form a lattice, a crystalline structure, three-dimensional order, and you can kind of think of ionic compounds as being like the magnetics toy with the little balls and sticks, but they, attach to each other, and they just keep going on and on and on. And so there's not really discrete molecules with ionic compounds. So I already covered that. Here's another illustration. Here's mercury. In mercury, this is a atomic element. It just has individual atoms. Mercury is a liquid at room temperature. It's a metal, and so it's shiny. It's really cool stuff, but it's also very toxic, sadly. Here we have a molecular element, chlorine. This is an element. It only has one kind of atom in it, and yet these guys are going around in pairs. They're not single atoms floating around. Okay, so there's 7 elements that do this. And these are the ones. And I think of these as the junior high girls of the element world. Do junior high girls go to the bathroom by themselves at school? No, you always take a friend, right? I was a junior high girl. I knew I was doing it, but I still couldn't help myself. I don't know what it is about junior high girls. I don't know what it is. Well, actually I do, but you don't know what it is about these elements, but they're always found in pairs. Okay? If they're not involved in another compound, they will not be single atoms. They never go out alone. They only go out with a friend. So hydrogen is always found as H2 when it's just hydrogen. Now, it could be involved in a compound where there might just be one hydrogen atom in that compound, but he's not by himself, or she's not by herself. Okay, so these are the ones that are we call them diatomic elements or diatomic molecules. And we look at their symbols here. Their formula is H2, N2, O2, F2, Cl2, Br2, I2. Okay, so element symbol with the subscript 2. And here's a way to remember those guys. So there's a silly sentence up there. Horses need oats for clear brown eyes. The sillier, the better. And I realize that the eyes part is a little bit of a stretch. But look at the first letter, horses. That's hydrogen, nitrogen, oxygen, fluorine, chlorine, Cl even, Br, bromine, and iodine. Those 7 are found as diatomic elements, and you need to know that, okay? This is important to know. Another way, if you don't like that one, there are 7 of them. If you start with number 7 on the periodic table and make a 7, those are 6 of them right there. And then, of course, why is hydrogen over here instead of being over there with the others? Because he's an exception to everything, okay? So he's off here running around by himself. He shouldn't be over there. But these are the 7. So start at the 7, make a 7 plus hydrogen, or remember the sentence. So compounds can be molecular or ionic. A molecular compound is going to only have nonmetals in it. Ionic compounds are going to have a metal most of the time. So ionic means metal. These basic units, for ionic compounds, we have what are called formula units. Because there's no discrete molecule, And so a formula unit is just giving us the lowest ratio of, say, sodium to chlorine. What's the ratio? Is it 2 to 1? Is it 1 to 1? Just what's the ratio? Because essentially every piece of salt, table salt in the shaker at home, is one giant molecule. It's just sodium chloride, sodium chloride, sodium chloride, back and forth all the way through. Molecules, on the other hand, molecular compounds have discrete molecules. This is carbon dioxide, dry ice in the solid state. And so it's got these carbon and 2 oxygens, and there's all these little individual molecules. I kind of just said all that stuff. Okay, so let's look at these. Before we can learn how to name things, before we can do this worksheet I handed out, we have to be able to identify what kind of a compound or element we're dealing with, because the names are going to be different for the different kinds of things. So chlorine. First of all, is that an element or a compound? It's an element. Is that an element that's found as atoms or molecules? I must be going deaf. I can't hear anybody. That's the Cl, chlorine, is clear. Horses need oats for clear brown eyes. This is a molecular element. How about no? NO. Element or compound? Compound. It's got 2 capital letters. So it's a compound. Is it ionic? Well, how do you tell? Does it have a metal in it? Is nitrogen a metal? No. Is oxygen a metal? No. So this is a molecular compound. Is this making any sense? Okay, thank you. Letter C. AU. Compound or element? Element. So from the symbols, you can recognize an element because it has 1 capital letter. If it has more than 1 capital letter, it's going to be a compound. See, chlorine is a molecular element, but its formula is Cl2. There's only 1 capital letter. That means it's an element. So AU is an element. Is that molecular or atomic? Atomic. It's not one of the 7. Is there a group of superheroes? There's 7 of them? No. I don't know. They keep making up new superheroes. Na2O. Element or compound? Compound. Ionic or molecular? Does it have a metal in it? So at this point, you can't just look at that and say, no, sodium's not a metal. You have to find sodium on the periodic table and tell me, is it a metal or not metal? So you either have a periodic table in front of you or you're turning around all the time, right? Where's sodium? It's way on the left side of the periodic table. Is it a metal? Yes. So this is ionic. If it has a metal in it, it's ionic. Cl3, compound or element? Compound. Ionic or molecular? Ionic. Chromium is a metal. Okay? Any questions about what we did here? Because if this didn't make sense, the next part's not going to make sense either.
Is ionic and atomic the same thing?
Ionic and atomic, are they the same thing? No, they're not. An atomic element has just individual atoms. Okay, they're not charged. You can't have an ionic element because ions have charges, and you can't just have a single element with charges. You can't just have a beaker of sodium plus ions. there has to be a negative ion there also. So you can't just have an ionic element. So ionic only refers to compounds, and our contrast there is molecular or ionic. Ionic is going to have ions, a cation and an anion, and then molecular does not have any ions in it. Does that help? Any other questions? Yes?
What about semimetals?
What about semimetals? Excellent question. We're not going to run into semimetals much in terms of nomenclature. And yeah, because they're just kind of in between and weird. So we're going to ignore them. How's that? Is that good? Any other questions?